Hello guys, now I have connected one power supply here and then one voltage regulator and then one bulb is connected in a series with that. Okay, and here I have connected one voltmeter parallel to what voltage regulator, that is fan speed regulator here, and we will measure the what is the change in the voltage across the fan regulator guys. Okay, now everything is off, there is no supply, and that's why what is the reading, watch here, the reading is 0. Is it clear? Because there is no supply. Now it is in off position. I'm going to give the supply, then bulb will not glow. And what about the voltage? Watch this, that complete supply voltage will come across the voltage regulator because it is off. It behaves like a off switch. And what is the resistance of this? Infinite, means the complete voltage, that is normally we are having the 230 volt supply. So 230 volt is here and that is across the voltage regulator. Remember, we are connecting the voltmeter parallel to what? Voltage regulator. Now I am going to change the speed of that. That is the first, just I have changed here, that bulb will glow. And what is the drop across that voltage regulator? It is reduced. Now it is what? 214 volt it is visible to you, right? This is the 230 volt, 214 volt nearly, means the drop across this switch decreases and drop across this will increase, and you are that is this brightness is visible to you. Now I am going to change the speed from 1 to 2. Then I am changing the 1 to 2, brightness increases, means voltage drop increases, current increases here. What is the drop across that? Only 187, means it will again further reduce. I am now increasing the speed up to what? 3. Brightness increases here, voltage drop across that regulator decreases. Now it is only 153 volt. Okay, or it is at speed number 3. Now 4. When I am giving the 4, so what is the drop here? 136, and remaining across the bulb guys. Okay, so that is what? Brightness again increases. Now it is not at high speed. At a high speed, what you want, that this will act as what? Short circuit, means directly it should be connected to supply, right? Bulb should be connected to supply, and maximum brightness we are getting, maximum voltage across the bulb we are getting, and what should be the drop across that switch? That should be equal to what? 0. Now what we are watching here, just I am going to make the full speed, that is the 5 volt here. Now when I am making it 5 volt, what is the drop across that? Is 0, means now this act as what? Short circuit. That supply is directly connected toward that bulb and we are getting the maximum brightness. Now we will get idea about regular speed type of speed regulator guys. Okay, so here we are not having a 1 2 3 4 5 types of speed. It will change the speed continuously. Then first of all it is off. When I am changing the regulator, then watch this, this is on, but it is at its what? Lowest brightness. Then I am changing the knob. So what about the brightness? Brightness increases guys, means the reactance of path decreases, but actually what we are using inside, we will learn about that. Now at a low speed, this type of voltage regulator will produce a humming sound, and that's why now these days these all are replaced by a step type of voltage regulator guys. Okay, done. Hello everyone, welcome to the Learn with Fun session. This is Sanjay Rathi. Now we have seen number of voltage regulators, that is fan speed regulator. We are controlling the speed by using this device, and that is very important one. Okay, now this is we can get the different speeds. Then here it is a step type voltage regulator, right guys? Now in this case we are getting some humming sound or noise at what? Low speed, and that's why we are using step type. And I am going to discuss the working of this, and I am going to give you the internal circuit diagram of this voltage regulator guys. And watch this, we are having some capacitor here, right? It is visible to you, internal diagram, that is the capacitor. This side there is a capacitor. Okay guys, now I am going to explain these capacitors and what is the circuit diagram, then how we are going to regulate the speed here. So this is the basic sign behind the fan speed regulator. This is the regulator guys. तो आप सभी ने यूज किया होगा और आपको मैंने बताया लाइट के अगर आपको ब्राइटनेस को भी कंट्रोल करना है देन वी कैन यूज द दिस रेगुलेटर. देखिए that is a circuit. Here it is a fan is connected and we are using this concept as a regulator block. We are connecting one capacitor and in parallel we are connecting what, one resistor. Okay, capacitor and resistor circuit, and that is we are giving the supply, that is a AC supply from this point. Then what is this block actually? Now I am going to explain this block here. We are having three blocks here. Watch this. For example, this is a 4-speed fan here. That is the off position. This is the speed 1, means low, medium and what, high speed. The fourth one is the high speed. So I have taken the 4-speed here. Now when we are giving the supply here, fan is connected here, one connection directly go to the fan. Then second one is here. When it is connected, this terminal is connected to off position, then this circuit is not completed. When this circuit is not completed means what, fan is off. Okay, in winter season that circuit is not completed, now the fan is off. But now when we want very high speed in summer season, then this is directly connected to fourth one. When it is directly connected to fourth one, watch this, then this supply is what, going upward directly to the fan, guys. Give me 1 minute. Yes, now watch this diagram. This is the direct supply here. This will complete, current will flow like this, and that loop is completed here, and it will run at high speed, guys. Okay, now that is the first case, and off and high speed discussed. Now for just low speed at 1, what will happen? This point is connected here. This point is connected here. 1 minute. This is the fourth one. This is connected here. When this is connected here means in between we are having one capacitive path, and because of that resistance of this path, or that is called reactance, will increase. Current will flow like this. This is in path, this is the path, and that is the closed loop. Okay, and now there is voltage drop across this reactance. Because of that, voltage across fan will decrease, as well as current through fan will decrease, and the speed of fan will reduce. Then at 2 means we want to increase the speed. Then what we are doing, simply we are connecting this capacitor, and that is the path. Now watch this. What is the value of the capacitor here? 1 microfarad. And what is the value of the capacitor? 2.2 microfarad. We have increased the value of the capacitor. Then how the circuit will work? When we are increasing the value of the capacitor, guys, what will happen? Reactance because of the capacitor will reduce. What is the impedance because of the capacitor? That is given by Xc is equal to minus j by omega c. So what is the magnitude here? 1 by omega c. The value of c increases, c will decrease, and that's why value of overall impedance will decrease. Okay, and therefore current will increase and voltage drop across this portion will less as compared to this portion. Similarly, for the speed third, we are giving current through this path. Now this is completed. This is the closed loop. Okay, so that is connected. Then what? Again the value of the capacitance increases 3.3 and 2.2. Then what will happen? More will be the current. Why? Because value of the capacitance increases means what about the impedance decreases? More will be the voltage across the fan, more will be the speed. Now if suppose you want to maintain one more speed here, then what you can do? You can connect this 1 microfarad and 3.3 microfarad capacitor in what? Parallel. We can pass the current through two paths, first and third simultaneously. Then we can maintain one extra speed here. In some cases we are getting now 1, 2, 3, 4 and what? 5. Then in that case directly we are passing the current through and this path. What will happen when the two capacitors are connected in parallel? The overall capacitance will increase. Then what about the impedance? Decreases, guys. And that is the concept of this fan regulator. You can also make by using what? Triac and diac. That is another concept. So in coming session I will give you the basic idea about that. Initially we are using the fan regulator with what? Resistors. But there was what? Power loss across the resistor. I square R loss. And that's why to increase the efficiency, now these days we are using what? Capacitor. Okay, so that is the internal diagram. Hope you have understand the concept. Do stay tuned with us, subscribe our channel, like the session and finally share the link of this session. Thank you.